We looked at quadratic inequalities in one variable last day, and we can see that just by inspection here, we're looking for where this inequality is less than 0. Okay, so if x is between -3 and 3, so for example, 0 squared minus 9 is less than 0, there's a solution. So our solution is between -3 and 3. Now, we often use a graph to help us with inequalities. And so the graph we're going to use is y squared minus 9, which is a parabola. Okay, and it has a y-intercept at -9 and 0 is at -3 and 3. Okay, so our y-intercept is at -9, and I know that's what this looks like because it's a parabola facing up, y-intercept of 9. And so how can I use this graph to justify my solution? Okay, between -3 and 3. Well, if I am less than, I'm looking at this part of the graph is less than, and since it's a one-dimensional, one-variable inequality, it's a one-dimensional solution along the x-axis, and the solution is going to be from -3 to 3. And I can see the solution in the two-dimensional graph. Now, it is a one-dimensional solution, but we use a two-dimensional graph to help us analyze this. So in general, if you have one variable, it's a one-dimensional solution along the number line. Two variable, we have a two-dimensional solution, and that will be area in an xy plane. So that's important to make sure we understand that generalization, because when we do a quadratic inequality in two variables, well, what is the difference between x squared minus 9 is less than y and x squared minus 9 is less than 0? Well, this is a one variable inequality where the solution is just the x along the x-axis. Here is a two variable inequality where the answer should be an area. Whereas here the boundary is 0. Okay, the boundary points are 0 where it crosses y equals 0. Here the boundary point is going to be the actual function, the function y. So the graph of this does not look any different than above. Okay, I still have my graph. It's a parabola. It's going to have the same x-intercept, same y-intercept. Okay, but now, as an inequality, my solution is an area, and the boundary for this area is going to be this line, or the actual y function, right there. And I drew it as a dotted line because it's not equal to. So the boundary here, in a one-dimensional or one-variable situation, is going to be the zeros. The boundary for the solution for a two-dimensional or two-variable situation is going to be the actual line. And we want to know what part of this graph is going to be what area part is going to be the solution. So here, if we understand that we're looking for y values bigger than the actual function line, we should be above the line. Okay, if we want y values below, we want to be below the line. If we're not sure, we can always test. Okay, so I'm pretty sure it's going to be above the line. So I'm going to test the point at 0, 0, 0. So I'm going to test 0, 0. Okay, and we could have also, remember that this is one of the things that we could do with our one variable as well. We can also test. Here we tested two variables, but we need to test both variables. So we're going to plug them in. 0 minus 9 is less than 0. Y equals 0. Yeah, that's correct. That's part of my solution. So I know that this area must represent the solution to that area solution to that inequality. And again, if I test some point on the outside, we should see that that point does not work. So for example, not that we should test 0, 0 is actually a very good test, but let's say we tested 7, 0. Y is 7 and x is 0. So let's test that. Is -9 less than, sorry, this is going to be y is 0, x is 7. So it's going to be 49 minus 9, so is 40 less than 0? No. Okay, we can see that it's outside of our boundary area. So how do the solutions differ then? The graphs are exactly the same. We're graphing the exact same parabola in both cases. So how do the solutions differ? Okay, so solutions differ in that in a one variable solution is one-dimensional and along the x-axis. Two-variable solution is two-dimensional and is an area in the xy plane. Okay, so there we go. So that's how that's a major difference between a one variable situation and a two variable situation. The boundary is the function and it's an area in two variables. The boundary are the zeros and it is the solution is along the x-axis for a one variable situation.